Hey, fellow engineers, and welcome to 2021 Festive Tech Calendar. Hopefully, you're all well and enjoying great content here on the calendar. I know I am. My name is Timur, and I am an Azure Solution Architect here in beautifully locked down New Zealand. Coming from many years of software engineering background, I help fellow developers overcome technical challenges. In spare time, I love solving good puzzles, helping people, and enjoying fine wine. Ideally, all at the same time. Big shout out to Gregor and Richard for hosting the event and being kind enough to let me join in the fun. Christmas has a very special place in my heart, and I could just not miss the chance to share the love. With pleasantries done and dusted, let us set the scene and dive right in. Have you ever wanted something so badly that you were seriously considering writing Santa a letter just to get it? Did you end up writing it? Did you end up sending it out? Or maybe you found a more productive way to achieve your dream. Anyhow, you probably have considered writing your wish down so you can at least keep track, budget, and make arrangements to get it done for Christmas. Delivery and fulfillment aside, today I wanted to touch upon technical side of managing wish lists, mainly in part where we use SQL to store and query JSON data. Your journey would likely start with a web browser. You may have installed an extension of some sort that would send information about item you're currently watching to an API. That API will have to make sense of all different attributes each website provides and try to store it in a way that makes querying as easy and efficient as possible. The catch is we don't know full list of attributes. And frankly, we don't care. It's almost Christmas, so why on earth would we want to waste time coding up a perfect data model when we can just lump it all together and chuck it into a schemaless data store like Cosmos DB or Mongo? And I think it is a wonderful idea. I, however, am somewhat conservative. I love dinosaurs and other tried and tested things, like SQL Server, for example. So that's what we will have to do. For today's demo, I created a simple table called Wishlist Entries. It has a couple of fields that we probably will not query on, such as customer ID and item source. And the most important one of them for today is item data. This is exactly where our JSON is going to sit. And as you can see, it's basically just a string. Nothing fancy. What may be of interest, however, is the way I populated the table with this data. I'm using Best Buy API's dataset that I found conveniently sitting around on GitHub. As you can see, it is an array of objects that represent an item. We're lucky that most of them have identical schema, so we wouldn't have to worry about that too much, but hopefully the point still stands. All I do in here is I basically go through every single item and I add it to the database. Nothing fancy, but that took me about an hour to do, and it has about 50,000 records, so hopefully we will have enough to play with. Moving on to coding part. Let us focus on data retrieval and skip the API part for now. It is a whole different can of worms and will probably distract us from our main point. From here on, we'll be exploring ways to query the data, but hopefully the point remains the same. Let's start with a simple console app. I'll call it Wishlist Demo. And I suppose we can use .NET 6. Now I'll proceed by defining my model so that it matches database schema. We'll just create a folder in here. Models and a class, and maybe let us call it wishlist entry. In here, we basically want to mimic the database structure. Yes, we could have used code first, but I kind of felt it's a bit more complexity that probably will distract us from the main point as well. So this will have to do. Oh, nice. Autocomplete. I'm loving it. Not customer name, rather item source. And since we do have a limit of 300 characters, I believe, we'll just set it in here as well. Although obviously this is not a requirement, but by any means. And now to the juicy part. We'll call it item data, and we'll not place any limits on that. Clean it up a little bit, and there we have it. Now, we want to install Entity Framework Core into here, so I'll just go ahead and do that. Another thing we want to install is, in fact, Newtonsoft JSON.NET, which I'll start with. And let's install the latest Entity Framework Core. Nice. Now we have to bootstrap our database context, which I will create in here. What do we call it? Santa's Helpers DB context. Sounds very creative. In there, what we want to do is bootstrap our connection string, which I'm hoping to still remember. And the way we do it is we use on configuring, or oh nice, it even has an autocomplete for that. So why don't we pull a predefined environment variable that I know points me to the right database. And this way I wouldn't have to reveal my super secret password 123 to you. Nice. Another thing we probably want to do is to see what kind of SQL gets generated, so we will also add some logging. And the easiest way to do it would probably be to just dump it out to console. Like so. Nice. A bit cleanup. Now, on to the main part. And this is where we start querying the data. Let's start with creating a new context in here. So I'll just call it new Santa Helpers DB context. Do I need to reference something? Yes. And the first cut, we will just try to access the data and DIY our JSON serialization. So it'll probably look something like so. Context. Oh, button. We still need to define the database set. And that will be wishlist entry. Right. This should work a little bit better, but let's find out. What do we call it? I don't really know what we're gonna filter it on, so I'll just select a few. Call it a wishlist entry, and I'll probably want to form a new object, so I'll call one the entry itself, and then we'll call the JSON bit Do we need to import it? Of course we do. Am I missing something? Is it not public? Yes, it is not public. So then now we should be able to just run it. First of all, as I said, we wanted to take just one or two and make sure that we run it by materializing the view. So this should be way better. And as you can see, we have got our results back, but the main part that I wanted to focus on in here is this query. As you can see, all it does, it just selects everything from wishlist entries. Obviously, this is less than ideal because we have to do it every single time when we want to query. Why don't we use a feature called value converters that allows us to kind of hide this functionality and package it nicely into the database context itself? But before we do that, I would like to quickly create another model that is actually our JSON object. And I know I mentioned that we will not really rely on the schema, but let's imagine that this is the most basic set of properties that every single object should still have. Otherwise, how do we query it? And we'll just go from there. So I'll call it item data. And given our example, it'll look something like so. I'll just cheat and paste it in here because it's not very material and it's very simple. So basically, all we care about is an SKU, a name, and a list of categories, which can have ID and a name. Very simple. Now, on to the value converter. The way you do it is you define it inside a context, and I believe you need to override another method in here called onModel creating. So what we're doing here, we tell it which entity we want it on, and we say we also specify which property. In our case, it is going to be a item data, and for that we say it has conversion, where if we have an item data that we want to convert back to a JSON object, JSON like so, and yes, we need to include the namespaces. And as for the reverse conversion, if we have a string and we want to get an object, it will be the other way around. So deserialize objects, and we actually have a type for it now, so why don't we use it like so. Am I missing brackets somewhere? No. What I probably am missing is the type, because now, since our property on the object is still a string and the deserialized object is going to be an item data, we just have to go ahead and update it in our context and our model in here. So now, instead of being a simple string, it actually becomes an object that we can later on query. See, fixed. What we can do now is we can literally say, hey, I would like to query everything. We don't even need this anymore. But maybe just for laughs, we'll leave it be and we'll call item data dot name. Let's see what's going to happen. And yes, the query is still the same, so we're not really any better off having done that. But the actual way we can run this query now is way more elegant, and I'm already liking it more. So the code is much cleaner, and I'm really loving the way we were able to achieve so much in so little time. We could probably just call it a day and go and have some drinks. But it still isn't using any JSON features. We still have to scan the whole table, and all filtering will have to happen on the client side. It works. Yay? Well, technically it does, but I really have issues having this sitting around in my queries. It just looks bulky and I don't like converting JSON myself. Is there a way to simplify this? Yes, there is. Entity Framework offers a feature called value converters. We can try and use that, but before, I would like us to define another model that is actually our JSON object so that we have easier time querying things later on. Yes, I know I said that we don't really care about schemas, but let us pretend that this is an object of a very small subset of fields that will always be there, and this is actually fields that we want to query on, so we kind of need it. Let's do that by creating a class, and I will creatively name it item data. We had a couple of fields, and I'll just cheat and paste them into here because they're very simple and there's not much going on in here. Just an SKU, name, and the list of categories. Each one of those is basically an ID and a name. Nothing fancy, but it will help us a lot. Now, on to the value converters. The way you would do it is you go to your context and override yet another method, which is called onModelCreating. Yes. In here, we find a property that we want to enhance. In our case, it will be a item data. And we will say that it has a conversion. This method basically defines a two-way actions or functions that Entity Framework will call every single time it needs to populate this property. So the first one is, I believe, serialization. So we have an item data object and we need to JSON convert it into our, so we serialize and we convert it into a string. So that will be a string. Oh. And now the backwards is we have a string and we want to deserialize an object into item data. And as you will see in a second, it is a bit interesting because we will have to do one more thing. And I want to specifically tell it to do item data. But as you can see, the compiler is not happy. And that is because now our property has to be of a different type. So let's go to here, and instead of a string, we'll have an item data in here. So our model basically becomes a item data, and we can query it. So to do that, let us maybe I believe we have to do like so. Let us maybe rewrite our query a little bit. So we want to select everything. We don't really at this stage care what, but we want to filter. And let's say we want to filter on item data dot category first. We know it's always there. But let's say we want to filter on, I believe it's called connected home and housewares, like so. Oh yes. Again, I forgot to materialize my query and it didn't run. Silly me. Right. Now we have an issue because Entity Framework refuses to translate it since there's no conversion that can be performed on SQL. So as you can see, it's basically requires us to download everything first and do filtering on the client side. So just for the sake of argument, let's do that. I think we have to say as enumerable in here, and then we can do our query. Let's try that now. And yes, it is so much better, but as you can see, the query is still not using any filtering whatsoever because, well, we couldn't. This isn't good enough. Just imagine all these people trying to query our API when we have an API and not being able to because it takes ages. I don't want to take responsibility for that many unhappy people and broken families. Let us have a look into what we can do on the server side. SQL has a function called JSON Value, and the way it works is, I'll quickly jump over to SQL Server to kind of demonstrate that. You just go ahead and select from wishlist entries where JSON value of item data, and we need to tell it where to look. So in our case, it is going to be category, and we only want the first one for now, name, and what was the name we wanted to filter upon? I believe it was connected home and housewares. So just take the first couple ones. So as you can see, it just filters them down. Now, the way we can leverage it inside Entity Framework is called method translation or DB function translation. The way you would do it is, let's jump back to Visual Studio, is we can define a method on the context and decorate it with an attribute that effectively tells Entity Framework to look for it and translate it if it finds it. Let's give that a go. So I will define a function. It has to be static, I believe. Call it JSON value. And it takes two parameters, right? So it is a string and another string, call it query, a path. The function itself does not need to do anything. In fact, it is standard to just throw an exception. Because it is not meant to be run by anyone. Where the magic happens is this DB function attribute. This is where we will tell it to actually go ahead and translate this call whenever it sees it into JSON value call. And just so SQL has easier time finding it, I believe we need to hint that it is a built-in method. We can also hint that it is not nullable, but that probably is not really going to help us. Now, how do we use it? So all of this can obviously go away. We don't need it. In here, we have our item data category. So all we have to do now is we have to go ahead and call context. And since it is a static method, we just call it on the class itself, JSON value. And we use the same filter that we just used inside SQL. So it will be category dot first name. Oh yes, now since it is an object and we tried our value converter, we actually have to undo that now. Let's quickly comment things out. We don't need them anymore. This and we need to revert our model back to string. Done with you. Now, let us try and run it. See what's going to happen. Right. Just have a look at this query. Isn't that very similar to what we've just done ourselves? And all we had to do is to define a static method and decorate it with an attribute. So this is letting us filter for values in JSON on the server side. And the only thing that we will download is the queries that the results that actually match the filter. So isn't that fantastic? I think this is a good state. I think this is where we could potentially have left it had we not had more things to try and do. But this is solid. This will work. But before we call it a day, let's quickly have a look at the execution plan. So I'll just copy this query and we'll pop it back into SQL Server. It is very similar to what we have in here. And we don't even need top, I think. Let's have a look at the plan. And yes, sure enough, all it can do at the moment is to scan clustered index because, well, we don't have any other indexes. So it still will do a full table scan, which is less than ideal. So how can we improve that? I guess the first thing that comes to mind, we can add indexes. And yes, it is a fantastic option. Let's try that. First off, just for laughs, let us try and index the whole column. It should be as easy as create index. We'll call it something, item data on wishlist entries and item data as a column. But sure enough, this type is not valid because it is a string that has unlimited length. What can we do then? Let us try to compromise a little bit. I propose to create another table and try and index that so that we don't lose all the data in our original table because it takes a little while to repopulate. How about we create a table called wishlist entries 1, and instead of maximum length in here, let us put a reasonable 1700 because this is what I believe the index can be, and we should be able to index that, right? Right. It still does complain a little bit about the fact that it is an n varchar, which means we actually have to go even further down in length. So Unicode 2 bytes per character, not gonna work. Right, dropping it. And let's go half that, 850. So that worked. That worked fantastically well. Now, let's try and insert the data into our table. And all I'm basically doing is just selecting from one and inserting into another. Let's give it a go. Oh no, some binary data would be truncated because, well, yes, we just limited the length of our column and the JSON is longer than that. Long story short, it is not going to work. Let's go back and explore our other options. What can we do? We somehow need to tell SQL that parts of our JSON are more important than the others. Remember how we already created an object in code that effectively outlines what we expect to have and what we want to be able to query upon. Let us just extract the fields that we want to query on and use them in code. SQL Server has a feature called computed columns that lets us do exactly that. It lets us extract one value and, well, surface it as a column, which can then be queried upon. The easiest way to do that would be to add a category column that is a result of running JSON value over our familiar expression. Or if we just add it onto the table, and then this query effectively becomes item category equals right. As you can see, way easier. But if we have a look at the plan again, we'll find out that it still is not using an index. Well, because we have not created any indexes. But this is the beauty of computed columns. You actually can create an index over it. Why don't we do just that? We'll start with maybe a simple index. We'll just literally index one column, right? Simple. Easy. Trying to run the query now. And no, it still is not picking it up. Why? Well, if I do this, I'm expecting to see a slightly different result. Namely, the index gets picked up. Turns out that SQL thinks it is easier to scan the whole thing anyway rather than use an index because it will need to go back and fetch extra fields. So then why don't we just add this extra fields to our index? We know we need it. We know there's no way around it. So we have to add it all in. If we do this, the index gets created. But now we can literally query everything in here and expect to see an index. Where's our plan? Yes. This should be as fast as it gets. It is a bit unfortunate that we had to include all the fields for the query to pick up our index. Better way would probably be joining a table with itself and using computed field to just filter down. But I can't seem to be able to demo it, so we'll have to park this idea. But yes, adding another column that is so huge to an index will basically double the table size. Anyway, at least now we have 100% index coverage and it definitely gets picked up. We just have to figure out how to use it from the code. And with that, we'll jump back to Visual Studio. Now that our table actually has one more column, we should probably add it. And let's add it to our model in here. So we'll just call it, is it called item category? Item. Now, since it is actually a computed column, we don't want Entity Framework to try and update it. And one way to do it will be to say that this particular field is actually generated. So all we have to do is to say that it is a computed column. So now SQL Entity Framework will not try to update it. And what we get out of it is we can actually use it now. So instead of doing this, which is all nice and dandy, all we have to do now is simplify. Right? Theoretically, this is all it takes. Let's run it. And let's have a look at our query. As you can see, it is still picking up everything, but now it is using that field to filter. And we've already seen that this particular kind of query will result in SQL picking up the index. Just to be sure, let us double check whether it is indeed happening. So I'll use the same parameter that I have in the code, and I'll just run it. What about our plan? Yes, we are definitely using our created computed column index. How awesome is that? And even though our application is far from complete, I think we are in a good place now. We can handle almost anything users throw at us, and we're still able to query data quickly enough. I think it's a kind of magic. Exactly what we need for Christmas. And with that, back to my slides. Well, that is all I had for today. If you enjoyed the content, please consider following me on social media for updates on my future shenanigans. That would indicate I'm on the right track and boost my motivation to keep going. Once again, thank you for watching and enjoy your holiday season.